All right, in this video, we are going to be finding the volume of solids rotated around an axis, but this time using a washer method. So this is the last unit of AB, and it goes real close to what we did last time, but when we rotate around a solid, or rotate around an axis, and that would give us a solid, but this time there's gonna be this little gap. So this is a washer. So notice there's like a little hole cut out. There's part of it missing. So if you thought about the cross sections in the last unit, all the cross sections were circles. This time the cross sections will be washers. So there's gonna be a little hole in the middle. So like on this picture right here, if I'm rotating around the x-axis, this is the area between here. This is gonna be rotating around, but there's gonna be a middle part that's gonna be cut out. This part through here is not included in the shape. So we're gonna have to subtract part of it. So if I have a horizontal axis of revolution, so I'm rotating around this one, maybe rotating around the x-axis, it's always gonna be like the volume of a circle minus the volume of a little circle. So the volume of the big circle, the big radius, the bottom of the little circle, the little radius. So I'm doing basically the volume from A to B of pi times the bigger radius squared minus the littler radius squared. And we were integrating with respect to x on this one. But this one I take out that pi because both of them have the pi, so I have this little formula. And it's the same thing if I'm rotating around the vertical axis. This time it'll be terms of y though. So let's just do an example. I think it's the easiest way to see this. It says, using the washer method, find the volume of the solid formed by revolving the region bounded by the graphs of square root of x and x squared around the x-axis. And we're going to sketch a graph to represent kind of what we're seeing. So I'm going to graph the square root of x first. So if I plug in 0, the square root of 0 is 0. The square root of 1 is 1. The square root of a half is, oh geez, it's 0.75, right? 0.7-ish. The square root of 0.5 is about 0.7, something like right here. So that's what the kind of the graph looks like, going from 1 to 1. And then from x squared, 0 squared is 0, 0.5 times 0.5 is 0.25. And then 1 squared is 1. Okay, so it looks like this. So that region is this overlapping part right here. And what I'm going to do is rotate that around the x-axis. So it's very similar to this. It's kind of hard to picture. But if I'm rotating that around 60 degrees, this shape, this is going to sweep around in a full circle and form a 3D solid. And then if I'm thinking about the cross sections, all the cross sections are perpendicular to the axis of revolution. So those cross sections, because it'd also be kind of like down here too. I'm gonna draw this real light. Maybe something like that. And it's rotating around all that over there also. So each cross section would be like a washer if I made that 3D somehow. So that's what each cross section is gonna look like. So if I add up an infinite number of areas of those washers, that would give me the volume. All right, so I have my volume formula. Volume is equal to pi. Okay, the overlapping starts at 0 and ends at 1. So those are my cross sections, go from all the way from 0 to 1. Those are my limits of integration. And then it'd be the big radius. So this is the axis of revolution. So the radius, the big radius would come from the blue equation. So what is that gonna be? The square root one. So I'm making a blue square root of x. That's the radius squared. Then I have to subtract the smaller radius. The smaller radius comes from that red function, which is x squared. And I'm gonna integrate that with respect to x. All right, so to integrate this, I'm going to first kind of clean this up a little bit. X squared, or square root of x squared, which would be x, minus x to the fourth. That's gonna be a lot easier. Reverse chain or reverse power rule. So be pi x to the squared times 1/2. That's ugly. Minus 1/5. Now if I write that from 0 to 1. Now if I plug in 0, that lower limit of integration, it'll just all zero out. But if I plug in 1, I get pi times 1/2 minus 1/5. And that would be my safe stop answer. But if I was doing this, I could get combining my term or common denominators, 3 pi over 10. So that would be the volume if I rotated that overlapping part around the x-axis. Now it's kind of like, if you try to visualize what that looks like, that it's almost like maybe like a little pot or a little vase, but just like sideways. I don't know. That's probably not helpful to try to visualize that, what that looks like. In class, I'll probably try to get an example. All right, integrating with respect to y, double integral case. Okay, so this is gonna be a little bit special. So, okay, so graph y equals x squared plus 1, x squared, so it starts here, over 1 up 1, over 1 up 2, so it kind of does that. Y equals 0, x equals 0, and x equals 1. So the part that's like bounded by those would be that region right there, and I'm rotating it around the y-axis, so vertical axis of revolution. Okay, so first I gotta think, okay, where are my cross sections going? My cross sections are starting at 0, and they're going all the way up to 2. That helps me, okay, I'm gonna erase that. Give me my volume is equal to pi times, it will go from 0 to 2, right? But if I think about that, this one, I don't need the washer from 0 to 1, but I do need the washer method from 1 to 2. And I need that washer method when I see there's that gap in between my axis of revolution and my graph. So this one, I'm actually gonna break this up into 2 parts. That's why it says the double integral case. And I'm gonna go from 0 to 1, and then I'll also go from 1 to 2, and they're different in each case. So in the first one, the radius is always 1, right? So it would be the radius squared dy. And then from the other ones where I need the washer method, the biggest one, because you go from big R to little r, the bigger radius is always going to be 1. So I'll say 1 squared minus the smaller. Okay, but I need to have this in terms of, with y's, right? So that equation is y equals x squared plus 1. I'm going to be integrating with respect to y. So I need to solve for x. So it'll be y minus 1 is equal to x squared, square root both sides. I'm going to do the positive square root is equal to x. So I'm going to say the radius would be y minus 1, square the radius, because I'm trying to find the volume of a circle, or area of a circle, dy. All right, so that's the setup. That's the hard part. The integration from here is pretty straightforward, but understanding this part came from just rotating, that's not helpful, rotating this around, right? And that just gives you a very, very basic cylinder. And then up here, I have a washer method because this shape is being revolved around. So it's not, it has that little part in the middle, like a little bowl part that's missing. So that's why I have to subtract. All right, so from here, we just integrate. Volume is equal to, okay, 1 squared, antiderivative of 1 is y, but plug in 1y. I'll just do it like that. Plus, okay, I'm going to clean this up first before I actually do it. 1 minus y minus 1. But the negative will go there, so this will be volume is equal to, actually plug in, so this would be just pi minus 0, so it's just pi plus pi, and then this would be like 1 plus 1, so 2 minus y. Take the antiderivative of that to give you 2y minus 1/2 y squared, evaluated from 1 to 2. Okay, plug all this in. This would be what? 2 times 2 is 4, minus 4 half 2, minus whatever I get when I plug in 1, minus 1/2. Okay, so final answer would be pi plus what? 2 minus 3/2, so what is that, 1/2? So plus 1/2 pi. So final answer, 3 pi over 2. The hard part is just setting it up. All right, so I'm gonna make this 2 separate videos. So thanks for watching, and hopefully it's helped.